always do this. That let f of x be equal to y, then we would know that inverse of y will give us x. So we always start with f of x equal to y. And let's say the first question is where the function is x plus 5 whole squared minus 7 is equal to y. Now I need to get x as subject of formula to find the inverse. X plus 5 whole square is equals to y plus 7. Square root both sides. X plus 5 is equals to square root y plus 7. Now I'm taking 5 on the other side. That would be minus 5 plus square root y plus 7. So finally, I can say that x is made subject and I can replace with f inverse y. So f inverse y is equals to minus 5 plus square root y plus 7. And then the question was f inverse x. So we can finally replace f inverse x is equals to minus 5 plus square root x plus 7.
How is both the x and the y the same?
They're not same. We substituted it. For example, the examiner would have asked f inverse of 9. Then I would have substituted 9 in this place.
Oh, okay. So
Why
it's
this was
just
y. Yeah, we
basically
just
like the.
replaced. Uh, we don't have to go in such detail every time. We just write this. And then question 2 is f of x is equals to 6 over x plus 2. Step 1 is equate with y. Y is equal to 6 over x plus 2. Step 2 is make x the subject of formula. So if we just cross multiply them, x plus 2 is equal to 6 over y. X is equal to 6 over y minus 2. Step 2 done, x made subject. Step 3 is replace. So f inverse x is equal to 6 over x minus 2. This is the inverse. We could have different forms. Both are correct or equivalent. Question 3 says f of x is equals to 2x minus 3 whole square. Now, as we already know that if we have a curve, it is a function, but when we find inverse of that, y is equals to x, reflection, this would look like this. Now, this is not a function because it is one to many now after inverse. If that was f of x, this is f inverse x. Now, it is not a function. For it to be a function, we could either select the part on right side of the turning point, the red case, or we could select something to left side of it, the green case. So it is around the turning point. So you see, examiner is already restricting x is greater than 1 by 2. So is restricting around the turning point. So first step is equate with y, and then we make x the subject. Square root y is equals to 2x minus 3. Square root y plus 3 by 2 is equal to x. And f inverse x is equals to square root x plus 3 by 2, which was valid for x is greater than 1 by 2. Find an expression for f inverse. When we have a turning point, it is accepted on right of it or on left of it. F of x is equals to 8 minus square root x minus 3. It says for x greater than 3. Obviously, we cannot have negative value inside the square root. Step 1 is equating with y. Now we make x this object. Y minus 8 is equal to minus square root x minus 3, negative on both sides. 8 minus y square root x minus 3, squaring both sides. 8 minus y whole square is equals to x minus 3. 3 goes on the other side. 8 minus y whole square plus 3 is equals to x. Now we replace x is replaced with f inverse x and 8 minus x whole square plus 3. Try question number 5.
Could you zoom into 5 a little bit?
Yep. There are two. F of x is 5x minus 3 for x greater than 0, and g of x is 7 over 2 minus x, and it says x is not equal to 2, and it is asking for inverse of both of these.
So is the first one, so f of inverse x equals to y plus 3 over 5? And then the second one, g of inverse x equals
If we are writing x,
two.
has to be replaced because we've already substituted it.
Oh, so it's be x plus 3. Okay. And then the second one, 2 minus 7 over g equals g of inverse x.
This thing,
Yeah, 2 minus, oh no, yeah, that's the same thing, yeah.
I think we would have x in numerator as well in this case.
In the g of inverse x?
G of x is equal to 7 over 2 minus x. If I'm replacing this with y, now we cross multiply. 2 minus x into y is equals to 7. 2 minus x is equals to 7 over y. Now minus x is equals to 7 over y minus 2. X is equals to 2 minus 7 over y. If you are saying this, then that's okay. If there's a full line, then that is not fine.
Oh, because when it's full, that means it's 2x, right?
Yes.
I mean, 2y. Okay.
We'll take the LCM.
Okay, that was.
Yes. This is it. Okay, number 2. Number 6. It says f of x is equals to x minus 4 whole square plus 5. Y is equals to x minus 4 whole square plus 5. Y minus 5 is equals to x minus 4 whole squared. X minus 4 is equals to square root y minus 5. X is equals to 4 plus square root y minus 5. F inverse x equal to 4 plus square root x minus 5. So number 6 is expression for F inverse x, that's done. And then we solve the p part. F inverse x is equals to 3. So 4 plus square root x minus 5 is equal to 3. Squaring both sides. X is equals to 6. Any confusion?
No.
I was looking at the question and just felt something wrong, and this is it. That was negative over there. I put positive. Quickly doing this again because there is one more way we could have solved part B. Okay.
We could have solved part B
Yeah, this was
because
the mistake.
yeah. Okay.
Because of this mistake, I was just solving that uh, like without writing in my mind, and I was getting different answers. I'll solve it again and show you.
Okay.
F of x is equals to x plus 2 whole square minus 5. Now for inverse, x plus 2 whole square minus 5, y plus 5 is equals to x plus 2, square root y plus 5 equals x plus 2, square root y plus 5 minus 2 is equals to x. Inverse function is minus 2. Examiner said in second part that f inverse x is equals to 3. So we have to solve for x. This was x plus 5 minus 2 is equal to 3. First of all, 2 goes on the other side. X plus 5 is equals to 3 plus 2. X plus 5 is equals to 5. Squaring both sides. X plus 5 equals 25. And x equals 25 minus 5. X is equals to 20. Now see, when we are solving this, x is equals to 20. That means in inverse, in this case, they should be switched. In this case, x should be 3 and y should be 20. Or let me say, in case of inverse, we substituted 20 to get 3, and in the other case, we should substitute 3 to get 20. Does that make sense?
In the inverse, it's substitute 20 to get 3, and then in the actual f of x, it's 3 to get 20.
Yeah.
Okay. So,
The-
wait,
This was,
the
this was unknown. Once we solved, now I know that actually in f inverse 20, this is 3. Like we substituted 20 to get 3.
yeah.
So other way around, In f of x, we should substitute 3 and get 20. I
Okay.
was trying. So now just guess for it. If you substitute 3 here, what do you get?
25 minus 5, so 20. Yeah.
20. Okay. So this is it, what I was doing manually without writing, and I was getting different answers. So where I realized that I made some mistake and I copied the question wrong because I was getting different answers. We should get same answer. So this question could have been, if there was this part, solve the equation f inverse 3. If the examiner could have asked, if a part was not there and he said solve f inverse x is equal to 3, and I knew the original question was f of x is equal to x plus 2 whole square minus 5. So I'm substituting x to get 3. In this case, I would substitute x to 3 to get x. That's opposite.
So
I'm
you would
substituting
substitute.
something to get 3,
Okay.
and in inverse, it is opposite. I'll substitute this to
Yeah.
get some. So that is 3 plus 2 whole square minus 5 is 5 minus 20. So see, without even finding inverse, I'm getting the actual answer 20
Okay.
because the relationship is true. F of x is equals to x minus 4 whole square plus 5. Now there's a turning point. So see, he always restricts, or else we can't find the inverse. X minus 4 whole square plus 5 is equals to y. X minus 4 whole square is equals to y minus 5. X minus 4 is equals to square root of y minus 5. X is equals to 4 plus square root y minus 5. F inverse x is equals to 4 plus square root x minus 5. Now it says solve the equation f inverse x equals f of 0. So this is f inverse x in f of 0. That is x plus 4 whole square plus 5.
What does f of 0 mean?
That value of x is 0. See, f of x was x plus 4 whole square plus 5. So f of 0 means x is 0.
Mm-hmm.
Similar way, without solving, let's just see. If we substitute 0, we're getting 21. So if we substitute 21, we should get 0. Okay, let me just solve. So this is square root x minus 5 is equal to 21 minus 4 is 17. No, no, that's different. So squaring both sides is x minus 5 equals, I'm using calculator, 289. X is equals to 289 plus 5. X is equals to 294. Try question number 8. First part says find G inverse X. And B part says solve G inverse X is equal to 5. Is it working?
I'm trying to do the A part, but
Okay.
Okay.
Making this
Hmm. I was trying to get it from the 2x plus 3 over x minus 1 equals to y. But, so what I did first is I moved the x minus 1 to the y. That's xy minus y equals 2x
are you
minus.
getting so this? Are you getting this?
No.
See, step one, we equate that with y. Now, step two is making x the subject. So if I just cross multiply, in order to separate all the x, I'll have to multiply that inside to split them. I'm collecting all the x on one side. Now take x common. Now x is separate, dividing it on the other side. G inverse x is equal to x plus 3 over x minus 2.
So the xy minus the 2x equals to y plus the 3. And yeah, we can take the x out from that one. And okay. And afterwards we can just put it back into g of x equals, yeah, g of inverse x
Clear?
equals to 5.
Yeah. So now this is 5. So x plus 3 by x minus 2. We'll do it both ways again. So just for sake of concept. See, we substituted something in inverse to get 5. So we should substitute 5 in g of x to get something. This x might be confusing. I'm writing a different letter. If we substitute b to get 5, we can substitute 5 to get b. Does it make sense?
Yeah.
So I can substitute 5 in g of x to get that answer. So that's 13 by 4 is equals to 3.25. Now let's see if we get the same answer. Cross multiplying. 5x minus 10 is equals to x minus 3. 5x minus x is equals to 10 plus 3. 4x is equals to 13. X equals 13 by 4. X is equals to 3.25. We're getting same answers. Question number 9. F of x is equals to x by 2 plus 2. Find f inverse. Y is equals to x by 2 plus 2. Y minus 2 is equals to x by 2. Cross multiply. Y minus 2 is equals to x. F inverse x is equals to 2 into x minus 2. D part says solve fg is equals to f inverse. We already have f inverse. I will work for fg of x first. I'm substituting g of x and f of x would mean g of x by 2 plus 2. That is x square minus 2x by 2 plus 2. Fgx done. Now this could be substituted. Fgx is equals to f inverse x. We copy paste the simplified forms. X square minus 2x over 2 plus 2 is equals to 2 into x minus 2. Now we solve for x. X square minus 2x plus 4 over 2, 2x minus 4. X square minus 2x plus 4 is equals to 4x minus 8. X square minus 2x minus 4x plus 4 plus 8 equals 0. X square minus 6x plus 12 is equals to 0. 12 is either 1 into 12, 2 into 6, 3 into 4. I'm not getting a perfect number, so trying quadratic formula. Minus b plus minus square root b square minus 4ac over 2a. And I'm getting a negative number inside the square root. 36 minus 48. There's something wrong. This was question 9. X by 2 plus 2, y is equals to this. We make x the subject, minus 2, then 2. That's fine. X minus 2. And then we substitute g of x in f of x. X square minus 2x over 2 plus 2x square minus 2x over 2 plus 2 is equal to inverse. That's 2x minus 4. Taking the LCM as x square minus 2x plus 4. Cross multiply. 4 and 8. Minus 6. Minus 4 already. That's 12 into 4. 48. Getting that error. Question number 9. No solution. Oh yeah. There's no mistake. 6 plus minus square root minus 12 over 2. No solution because there's a negative number under the root. Clear?
Yes, because inside the square root can't be negative.
And we take them. Try question 10. Is it readable?
I also opened my book, so it's okay. there's still no solution for this one, no?
Maybe.
Because if we were to get the inverse of g of x, wouldn't that be a negative 271 inside of it? A
If
square root.
you're giving 0, let's see. First of all, you substitute ng, that is 2x squared plus 2 plus 3. And on the other side, that's inverse. I'll have to work for that. Y is equals to 2x plus 3.
Y minus 3 over 2.
7 minus 3 is 14. 7. 2x squared plus 2 plus 3. So first of all, 3 goes on the other side. This is 2x squared plus 2 is equals to 4. Now we divide this 2. X squared plus 2 is equal to 2. Now we take that 2. X squared equals 0. So x equals 0. We're getting a
Oh,
solution.
oh, okay. So it's not no solution. It's still 0.
Yeah,
Okay.
there's a value. Okay. F of x is 2x plus 8 by x minus 2, where x is not equal to 2, so that the denominator is never 0. And g of x is also given as x minus 3 by 2. I have to find f of x equals g inverse x. So first going for the simplified form for g of x, g inverse x. Y is equals to x minus 3 by 2. 2y is equals to x minus 3. 2y plus 3 is equals to x. So we can say g inverse x was equal to 2x plus 3. So the condition was we equate f of x and g inverse x. F of x is equals to g inverse x, where f of x is 2 plus 8 over x minus 2, and the inverse is 2x plus 3. Cross multiplying, 2x plus 8 is equals to 2x plus 3 into x minus 2. 2x plus 8 is equals to 2x square minus 4x plus 3x minus 6. 2x plus 8, 2x square minus x minus 6, rearranging. 2x square minus x minus 2x minus x minus 8. 2x square minus 3x minus 14. So that's 28. 1 into 28, 2 into 14, 4 into 7, 4 into 7. 2x square minus 7x plus 4x minus 14 is equals to 0. X common, 2x minus 7. 2 common, 2x minus 7. X plus 2, 2x minus 7. X plus 2 equal to 0, x equals minus 2. 2x minus 7 equals to 0. 2x equals 7. X equals 7 by 2. So minus 2 and 7 by 2. This was question 11. Minus 2 and 7 by 2 is 3.5. Okay, now the nature is changing a little. He's asking about range also. Question 12 says f of x is equals to 3x minus 24, where x is greater than equal to 0. Write down the a range of f inverse. So f inverse x is greater than equal to 0. Question done.
Obviously, inverse would be just the value of x.
Yeah. What was the domain of f of x will now be a range of f inverse x and vice versa. If we say f of x, if I say a to b is domain and I say c to d is range, so in f inverse x, a to b will be range and c to d will be domain. They interchange. The domain was already given, now that is range. Okay. So we have f of x, we have g of x, it says express x square minus 6 in terms of this. Now we have to understand which side is it and how would this become. So f of x is equals to x plus 6, where g of x is equals to square root x. Express x square minus 6 in the form f and g. Okay. Minus 6. Thinking of substituting g of x in f of x, I would get square root x plus 6, but not minus 6. And minus is, I guess, only possible if I take the inverse. And square is possible when I take inverse of g. That should be g inverse. So I'm trying those inverse. Looking at this is y is equals to x plus 6. Y minus x equals x. So f inverse x is equals to x minus 6. Does that make sense? I can get minus 6 when I take this on the other side. And that happens only when we go for inverse.
Mm-hmm.
And then looking at this, y is equals to square root x, squaring both sides. Y square equals x. So g inverse of x is equals to x square. Now if I just substitute this here, I'll get that original equation. So basically f inverse g inverse of x is equals to x square minus 6. So this expression right here, f inverse g inverse x is responsible for this.
So it's x squared minus 6. Wouldn't the x squared multiply with the x?
Now we're substituting inside that fraction. See, f inverse is this. So you
Yes.
substitute this whole g square inside this.
Okay.
Okay, 14 says f is given, g is given, h is given, state which of the following f of x, g of x, and h of x has an inverse. So first of all, f of x 3 minus 2x, although the domain is given, but irrespective of that, it is a straight line. So yes, it will have an inverse. Now the second says G of x is equals to 3 minus 2x mod. Now it will have a turning point. Where will it have a turning point? 3 minus 2x is equal to 0. 2x is equal to 3. X is equal to 1.5. It will have a turning point at 1.5. So if we just sketch it, this is x 1.5. This would look like this. It will have an inverse if I select everything to right of the turning point or everything to left of the turning point. But what does the domain say? 0 to 5. 0 to 5 says the examiner is selecting this part. So it will not have an inverse because it would become one to many when we take the inverse. Third is h of x is equal to 3 minus mod of 2x. So turning point is x is equal to 0, x is equal to 0, and y is equal to 3. The turning point is x0, y3. Now when we go for that, this is x0, y3, but due to this negative sign, it is a sad face. But still, turning point is x0, so either to right of it or to left of it. Now let's see what the domain is. The domain is 0 is less than equal to x is less than equal to 5. So the examiner is selecting this part only and this part. So see, in this part, there's no turning point. So yes, it would have an inverse. Any confusion in these three?
So the first one has an inverse because it's a straight line, and the second one doesn't have an inverse because of the range. And
Uh,
the
do- because the turning point is within the domain.
yes, so we can't go outside of it. And the
Yeah.
second, and then third one doesn't have an inverse, so it's only the first one.
No, third is yes.
Third one has
Because
one.
yeah, because we discarded what is on the other side of the turning point because of this.
Okay, so
See if I stitch like let's say f of x is equals to x minus 2 plus 3 and this is squared. So this would be x2 y3 2 comma 3. And now see, I say that we draw from 0 is less than equal to x is less than equal to 5. So that would be a no. Then we draw from 2 is less than equal to x is less than equal to 5. That will be a yes. You see, 0 to 5 is something this. 2 to 5
mm-hmm.
is something this. We are discarding the other side of the turning point. If I say we draw from minus 7 less than equal to x is less than equal to 2, that's again a yes. Because turning point, the other side is discarded. If we draw from like 4 to 9, that's again yes. Because 4 is somewhere here, 9 is somewhere here, and within this region, there's no turning point. So if there's no turning point, that's a yes. Because
And
after
okay, so
turning, it would not give us one too many.
okay, so then this one also the turning point is inside the range. I mean outside the range, so that's why it has a turn. That's why it has an inverse.
Yeah.
Okay.
Minus 8 less than equal to x is less than minus 6. Yes or no?
Yes.
Minus 10 less than x less than 10.
No.
This is what we did. Okay. Try number 15.
Is A square root y over 2?
We are looking for domain of F inverse. You just found F inverse. Y minus 2 is equal to x square. X is equal to square root x minus 2. F inverse x is equals to x minus 2. You may have this path to solve the question, but it is not complete. We need the domain. Do you know how to do it?
I'm thinking about it. I think
See, this is the main function, and we know that domain is x is greater than equal to 0. If I would substitute that 0, may I say f of x is greater than equal to 2 for this given domain? Only f of x. We're talking about only f of x. For this given domain, the range is f is greater than equal to 2.
if we were to put f of x into the
Yeah,
domain,
the values of x, we will get f of x greater than equal to 2. Like if I just go for this sketch, when x is 0, this is 2. When x is 1, this is 3. When x is 2, this is 6, and so on. So we would know that the lowest value is 2 and all values are above that. So f of x is greater than equal to 2 for this given domain. Would you agree to these two things? In fact, the first one is already given. Would you agree to this range?
okay, because it's above the 2.
Yeah. So for the inverse, whatever was the range is now the domain.
So f of x is greater than 2?
Yeah.
Oh, x is greater than equal to 2.
What was the range is now the domain. And you can also see that through that this would just satisfy this because you cannot have value less than 2 or else it
Also,
would be negative answer.
okay, so the domain of f inverse 1, f inverse x is going to be x is greater than or equal to 2.
Yep.
Okay. And the range for
No, it's
G
not
inverse.
asking about the range, but if we would, then range would be what was the domain.
Okay. No, I
Just
was
in
just reading 15b.
sorry.
I was just reading 15b.
Okay. So g of x is given 5x minus 4. X is greater than equal to 0, and he's asking a range. So range of inverse. The inverse x range. So what was once the domain is now the range.
So f of x is greater than or equal to 0.
The
I mean,
inverse
g
x
of inverse.
is equal to 0. What was the domain is now the range. The function f and g are defined for x belongs to real number by f of x 3x minus k, g of x is given. Find an expression for f inverse and g inverse. Y is equal to 3x minus k, y plus k is equal to 3x, y plus k over 3 is equal to x. F inverse x is equal to x plus k over 3. On the other side, g inverse g of x is equal to 5x minus 14 over x plus 1. Y is equal to 5x minus 14 over x plus 1. Cross multiply. Xy plus y is equal to 5x minus 14. Xy minus 5x is equal to minus y minus 14. X common. Y minus 5 minus common y plus 14. X is equal to minus y plus 14 over y minus 5. I'm absorbing the negative sign in the denominator. G inverse x is equals to x plus 14 by 5 minus x. And then it says f inverse 5 is equal to 6. F inverse 5 is equal to 6. So we copying that equation and substituting 5. K is equal to 18 minus 5. K is equals to 13. And C part says G inverse into G of x would be just x. We put inverse in function or function in inverse, it would lie on y is equals to x. 16C is just x without solving. Any doubt?
No.
One last question. Let's do that. F of x equals x cube for x is real, belongs to real number, g of x is x minus 8. And we'll be a little careful with x cube. No need, because we're not having such critical turning points. This is cube and it is just cutting at one point in both directions, so no issue in having an inverse. And the other one is linear already. So it says express each of the following as composite function using only f, g, and f inverse, or this. It is just exactly like question number 13. Okay, try this question.
Just like question 13.
It is like question number 13. Like we would need some expressions like f, g, f inverse, g inverse. What would this be? What would this be out of these? Okay.
Okay. Could you just do A just for like demonstration?
Yeah. Okay. So f of x is x cube and g of x is x minus 8. And what the examiner is asking is x minus 8 raised to the power 1 by 2, 1 by 3. So I can see that This is g of x. But where is this coming from? So it must be inverse of that. So if I go for inverse of f of x, y is equal to x cube, cube root both sides. So f inverse x is x1 by 3, right?
Mm-hmm.
Now inside that is x minus 8, which is clearly g of x. So when we put that inside it,
So
x minus
yeah, that.
8 by 3 is actually responsible du to f inverse g of x.
Oh, okay. Okay.
So this is f inverse g of x.
Yeah. And then the second one would be g f of x.
And you're saying g f of x. So if I would just substitute here, I should get negative 8. That's positive 8.
Oh,
So there's something again changing with g of x. Let's find that inverse as well. May I directly write that? That's easy. We're just going to take 8 on the other side. Like f inverse x is x1 by 3. We have all four now. F of x, g of x, g inverse, f inverse, right?
mm-hmm.
Now see what b would be.
So then it would be g inverse f of x.
Correct. C part,
So that would be g inverse. No, g of f inverse x.
we are substituting f inverse in g. Yes. And the last one.
Also, then that would just be f inverse g inverse x.
F inverse, g inverse x. Correct. Okay, now I'll just touch this topic and in your free time do try that. Graph of function and inverse. We've been doing graphs irrespective of if the expression is a function or it is an inverse, we can always sketch it. We just need the equation. So for example, this one right here is 2x minus 1. We could sketch it. Yes. If I would make the inverse, find the inverse. This is the inverse. We could sketch it. Yes. So that's not an issue. The important thing to understand is that the relation between them is a reflection in y is equals to x. X becomes y becomes x. Domain and range would become a range and domain. Domain would become range would become domain. That is a reflection in x-axis. For this particular, the one in blue, I can say the domain is -1 to 3 and the range is -3 to 5. So see the one in blue. Now the one in red. The domain is values of x -3 to 5 and range is -1 to this is 3. See, the domain becomes the range becomes the domain. They are a reflection of each other in y is equals to x. Any doubt in this concept?
No. And then the point that they intersect in
That
is
is x equals x. Always, like if I would say f inverse x is equals to f of x. So we can say x is equal to x or y is equal to y. Y is probably not there anytime. X is equal to x.
okay.
And that is why when we are asked to solve this, so the answer is without solving, answer is x,
Mm-hmm.
where substituted with each other.
Okay.
See, x square minus 2, examiner is selecting the one after the turning point or before the turning point. It could be anything. But the turning point should not be there in order to have an inverse. So this is the line, and we just draw the line y is equals to x and solve for it. So this value definitely stays there. This is x2 y0. So we just swap those points. We make x0 y2, and this last point is x5 of y9. So we swap these points, x9 and y5. So this will be the sketch of inverse reflection in y is equals to x. If you get time, do go through this, and if you like, definitely we'll discuss if there's any. And this is not a function. You see the turning point is there.
Mm-hmm.
This is one too many. If I draw a line here with one x, I'm getting different y. So we would definitely select the turning point first. So either draw to right of it or we draw to left of it in
So
order to for
that.
them to have an inverse.
Okay.
Anything you would like to ask?
No.
See you next class then.